Hi everyone, welcome again to another video of SAT Math Explained. Today our topic will be lines, angles, and triangles, which is within the geometry domain. So after this video we're only going to have two left, and then the SAT Math Explained series will be over. But it'll only be over for like the focus skills specifically, like all the College Board domains. But if you guys have a specific topic you want me to go over to, like let's say factoring or triangle similarities, similarity congruency, or anything, any specific topic you guys want me to go in depth, let me know in the comments. I'll make sure to make a video about it. And let's get started. So mostly what this focus skill consists of is angle hunting. So one of the most important things is to know the basic skill of complementary and supplementary. So supplementary is when, let's say, supplementary is, let's say, when A and B add to make 180, where A and B are both angles. Complementary is when A plus B add up to make 90. So supplementary means straight line. Complementary means that's not gonna work. Okay. Complementary means right angle. So an example, if you guys, I just put this example. So an example, let's say for complementary, for supplementary, let's say this one's A, this one is A, and then this one is B, right? And so because this is a straight line, A and B are supplementary. And then an example for a right angle would be, I don't think there isn't any, but let me just give me a minute. So if you have like this, something that would be complementary would be these ones. So let's say this one is angle C, this one is angle D. Angle C and D are considered complementary because they add to make 90. But let's say they have to also be next to each other. Like you can't have like one on the other side of the shape and say, oh, it's complementary. I'm like, technically it's complementary, but that's not the way the words are used. So then know about transversals and parallel lines. So a transversal it just means something that intersects a line. So like this, these are two parallel lines. This is a transversal. The red line is a transversal because it just like goes through them. So so in this example, let me just erase this. So in this example, let's assume it'll be given if they're never assume they're parallel on the SAT. It will always tell you like line L and M are parallel, and the notation for that is like this. It's like an arrow in the middle of the line, so like this. So let's assume L and M line L and line M are parallel, and then P is a transversal. This is a transversal. P is transversal, K is transversal, J is transversal, but for this we're only going to focus on P. So basically, the most important part about this is to know about corresponding angles. Basically, when you have two parallel lines and then a transversal or something that cuts through them, corresponding angles will be equivalent. So what's an example of that? So like this one over here corresponds to this one. Like they're the same thing, but on different sides, if that makes sense. Sorry, I'm using the So we're referring to line P. Remember that. And so then right here, this is it corresponds. So like if it's the same thing but below. So it corresponds to this one. So I know that this one is equal to this one, if that makes sense. And let's say on the same thing, this one on the left side, same thing. It's equal to this one, 40, because you have two parallel lines, a transversal, and they're corresponding. And I'll show us a lot of examples if it doesn't make sense now later on. And so recall algebra. Sometimes you're going to have some questions like basically you're going to use the supplementary angle hunting basically. This is part of angle hunting, about knowing transversals and all of that. But then you also have to recall algebra because sometimes, like let's say, okay, you finally solve it, but the thing is it wasn't x. This might have been like something, an expression like 2x plus 6. From there, you have to use basic algebra skills to solve for x. So that's where it will likely be used. And then no similar triangles and quadrilaterals. So just similar just means they have all angles are equal. So all angles are equal. So all the angles are equal, but it's a different size. So it's basically the same shape, but shrinked up or shrinked down. And it also applies to squares. And yeah, so know those, so know when to recognize. For quadrilaterals, there aren't really like ways to recognize. The only way to like there aren't any tricks or shortcuts. Mostly it's just know just know just pay attention if all the angles are equal, then you would know that it is similar, which will most likely be necessary for answering the question. And then for triangles, you just have to know I mean, most of the times it'll be mostly obvious, but you just have to know like, okay, I have angle, because that means yeah, most of the time if you have two angles, that's a similar triangle. That's most likely the case that will show up, and that's most likely the case that will show up. And I'm pretty sure the other one was if you have like an angle, a side, and then an angle. That was another one. If you guys want a short video about it, let me know and I'll make sure to make one. So how do you solve that? So this is it for what to know. It's very basic. But how to solve? First thing, just look at the diagram, look at the question. What angle or what side? Because it's not always going to be angle hunting. Sometimes they want you to solve for a side. So what angle / side do I need to solve for? That's the most important thing. And then what information is given. Basically, know how to interpret the diagram, look at the information, and know which information relates to this. So, like, which ones can I use? Where can I use supplementary, complementing to help me in maybe maybe I can use a corresponding angle with a supplementary angle to find the side. You have to just look at the diagram, and then try to just find how all the numbers given can correlate, which is why it's called angle hunting. Because basically, like, it's not like one set way. You have to like keep trying, and like just apply all the skills that you know, which is apply angle / length hunting skills. So yeah, and then answer the question. So that's it for how the procedure. Let's move on to examples. As usual, please try to solve the questions before you watch my explanation, because just watching me gives you a false sense of understanding, which will not help you on test day. And so, as usual, we do 2 easy questions, 2 medium questions, 1 hard question. So let's get started with the easy. So this one tells us that in the figure above, lines L and M are parallel, y equals 20 and z equals 60. What is the value of x? So this one, the information is not in the diagram. The information is in the text, and we have to add it to the diagram. So we're told that y is equal to 20, and then z is equal to 60. And then we're asked to solve what is the value of x, so up here. So looking at this, the first step is, I need to solve for this angle up top. How can I relate the information? So as soon as I look at this, I see that there's x and 60. So first thing I'm thinking, I forgot to say this in what to know, but it's given in the reference sheet technically. The three angles of a triangle at sum to 180. Yeah. So that is technically given in the reference sheet. So if you do forget for some reason, you can just click on the reference sheet. It's gonna say on the bottom. But yeah. So first thing I look at this, I see x and I see a 60. So what I'm thinking, I want to try to get this angle so that I can use the information that 3 angles add up to 180. The 3 angles of a triangle add up sum to 180. So I want to try to solve for this angle so that I can apply that they all add to 180. So I have 60 plus x plus an unknown thing is equal to 180. So how can I solve for this? Then I look down, I notice that they gave me angle 20. Right? And also I realize they tell me that lines L and line M are parallel. So this one, L and M are parallel. So, and then I can see that this one is a transversal. This is a transversal. It's cutting through the both lines. So then when I look at this, I want to find this angle again. We're trying to find this angle. So when I look at this, I say, okay, they gave me 20. Why did they give me the 20? And then I think of corresponding, because I have the 2 parallels and a transversal. I see that angle y right here. So it's like the top right of, like, let's say you have like 1, 2, 3, 4. I can see that angle 20 or angle of the y is in the top right. And then up here, the one I want to solve for is in the top right. So then I know that this one is 20 because it's corresponding. So 20. And then from there I can just solve for 180. So 60. And you could put this into Desmos technically. Plus x equals 180. Then if you want, put it into Desmos. Sorry. Plus x equals 180. And then I solve for x. X is equal to 100 using basic algebra. X is equal to 100. So yeah, that is how you would solve this. So I just want to show an other like what if example. So let's say you had all of that, but let's say instead of y is here, instead of y being right here, let's say y wasn't here, and they gave me y over here. So what I could have done was basically, it's still corresponding with this, it's still two parallels and a transversal. I could have said, okay, so y is equal to this angle right here. And then from there, I can realize that, okay, it's a straight line, so they're supplementary. So I would do this, so I would do y, technically, let's say y2. It's the same thing, let's say y degrees is here. And then so I know it's equal to 180. So this question mark, so it will be question mark, the unknown, this is the question mark. So question mark plus y degrees is equal to 180. Because it's a straight line. So that is how you would use the corresponding and the corresponding and the, what was it? Supplementary and complementary together to be able to angle hunt. The second question says that at a certain time and day, the Washington Monument in Washington, D.C. casts a shadow that is 300 feet long. At the same time, a nearby cherry tree casts a shadow that is 16 feet long. Given that the Washington Monument is approximately 555 feet tall, which of the following is the closest to the height in feet of the cherry tree? So what I'm seeing from here, it's giving me two pieces of information, like two relevant pieces of information for two different things, and then it gives me an additional one, but it doesn't give me the last one. What I mean is it gave me the shadow length for both the monument and the tree, but it only gave me the actual height of just the monument. It didn't give me anything about the tree, so what I automatically think is there's going to be a ratio involved. So I'm going to have to set up a ratio and then solve. And so if you guys want, if it helps you guys, you could draw a diagram. Or, yeah, if you guys want to, yeah. So you could draw the picture. So let's say this is the Washington Monument. This line is the Washington Monument. Like that. Okay. So this is the Washington Monument, okay? And this is how many feet? It told us that it is 555 feet. So 555 feet. So we can imagine it as a triangle. And so then the shadow that is given is 300 feet long. So that would mean if we're imagining it, we could imagine that this is the shadow that it's giving, and it is 300 feet long. The shadow is on the ground, so it's 300 feet long. So we could imagine that it's like a triangle, right? Like a triangle like that. And then, so it's the same time, the same angle of the sun. So we're going to assume that this angle is the same thing. So this angle is the same thing. This angle is the same thing. And so then by angle, we can know that they're similar. And so then the tree would look the same thing, except this we don't know. We don't know the height. This is the tree. And then the shadow length is 16 feet. The shadow is 16 feet. And then it is also a triangle. And then because it's the same time of day, we know that the sun, like let's say this is the sun. The sun is like shining the same way. Like, yeah, like that. So because it's shining the same way, this is going to be the same angle. Then we have the right angle that's the same because it's just straight tree and then a shadow on the ground. So that's going to be perpendicular. So then we have this one and this one. So then I know by angle, like I said, they're similar. Then from there I know that because they're similar, I can set up a ratio. So you could then have gone the diagram way, or you could have just read it and then interpreted it. Interpreted it. And so then, the ratio would be, so 300 divided by 555. And just make sure, it doesn't matter if I flip it, I just have to flip it for the other side. So here I put the shadow on top, so for this one I also have to put the shadow on top. So 16 on top, over x. And then I just have to solve for x. I'm going to cross multiply. I get 555 times 16 equals 300x. 300x. Then you can put this in Desmos and see the graph. I'm just going to do it like this. I know that x is equal to this thing. So x is equal to this thing. I'm going to put that into Desmos. So putting that into Desmos, 555 times 16 all divided by 3, that's 300. I get 29.6, and that is, which is long as close to the height. It says closest, the closest answer is C in 30. So that is how you would solve this question. And as always, if you have any questions, please let me know in the comments. So this one, oops. But anyways, so this question, and it says in the figure above, AF, so this thing, AF, BE, and CD are parallel. Okay, so they're all parallel. And points B and E lie on lines AC and FD. We can see that in the diagram. So if AB is equal to 9, so they're telling me that this length is equal to 9. They're telling me that BC is 18.5. 18.5. And then FE is 8.5. So FTE is 8.5. What is the length of ED to the nearest tenth? So this is similar to this problem, except it requires you to recognize similarity within a quadrilateral. So how do you do that? They have to be the same angle. So how do I know that they have the same angles? Basically, I know that this one is parallel to this one and this one. So then you can't just assume they're similar because they look similar. So basically, you have to think about the corresponding lines. So if we assume that we look at these lines of the trapezoid as a transversal, which it is a transversal. But let me just make it more clear. Okay, so it's like that. So then I know that this angle is equal to this angle because it's corresponding, and then this angle on the bottom is equal. Let me do it in a different color. This angle is equal to, so the bottom right, let's say, bottom right, the inner bottom right is equal to the inner bottom right, and then so on, and then this one is equal to this one, and then this one is equal to this one, and so on. So then, based on that, I know that they are similar, based on the corresponding angles. So that would mean that all the angles are the same, and I know that they're corresponding. So from there, same thing, I can just set up a ratio real quick. I'm going to do the bigger over the smaller, so I'm going to get 18.5 divided by 9 is equal to 8.5 is smaller, so I'm going to put it on the bottom, 8.5 times x. And then from there, I just solve for x. Same thing I did last time, so it's going to be 8.5 times 18.5 divided by 9. And I put that into Desmos. I'm not going to change the screen, but I'm just going to type in Desmos. The answer that I get is, divided by 9, 17.47. 17.47, and it says to the nearest tenth, so that rounds up to 17.5. And that is how you solve this question. The second medium question. This one says triangle ABC and DEF are shown above. Which of the following is equal to the ratio BC over AB? So I want BC. Which of the following is equal to the ratio BC over BC over, so BC over AB. So from here, it might look confusing, but then you look at the answer options, it's not asking for a number, it's asking for relative to triangle DEF, because all of them are like D over DF. So this, at first it might look confusing, like how am I going to solve this? But then you could recognize that basically, so this is 90-degree angle, we know that, so that's 90. 90. And then this one's 32, this one's 58. You might think, okay, it's not similar. They're not, there's no angle. But then if you look here, 32, this side, if you do, okay, so if you do 90 plus 32, you get 32, you get 122. Sorry. That is equal to 122. And 180, because three angles of a triangle, 180 minus 122, you get 58. So 58. And then for this one, it's going to be other way around. But in the end, you find that they're both similar, actually, but they don't. You have to actually realize that they don't make it as clear as other problems will make it for this one. So then from there, okay, they're similar. Does that mean I can just assume, okay, this is one, this one's the long, this one's this one? No, because they're not oriented the same way. As you can see, for this one, the 58 degrees is right here on the bottom. So this one's right here. Okay. It's right here on the bottom left. Oops. Okay. Bottom left, and right here 58 is on the top left. And it's the same thing. So how can we look at this? To find, we're asking for, this is how I would look at it. You could like try to think about flipping it on its side or something. for me that confused me, so I'm just going to say, okay, the top part is BC. So BC is between the 58 degree angle, so 58, and the 90. This is BC. It's between 58 degree angle and 90 degree angle. So now look here. This is the 58 degree angle. This is the 58 degree angle. This is 90 degree angle. Right here. So then that would be DF. DF is the numerator. DF. And I'm going to divide that by it says AB. What is AB? A to B is between 32 and 58. So between 32, remember this is 32. 32 and 58 is D to E, line DE. So line DF over line DE. Okay. So technically it doesn't tell you, but it turns out that they actually give it to you technically in the problem, because they don't tell you that they correspond, but it's technically a coincidence because they don't want to tell you. But AB did correspond to DE, DF did correspond to, never mind that. Ignore what I just said. They do not correspond, and they did that on purpose. So as you can see, so AB does correspond to DE, but then BC actually corresponds to EF, not DF. So they did it on purpose so that you can't just like look at the letters and like say, okay, first letter over and first letter, second letter, second letter. And so we got DF over DE, which is option B. And then so that is it for the medium questions. Let's move on to the final hard question. So for the hard question, it's mostly like the same thing. It's the same as the other problem. It's just more work. So it's not more work, but it just includes more information. So it might be overwhelming for some people. So but if you just like treat it as a bunch of small triangles, like see, okay, this is one small triangle, this is a big triangle, and like that's a quadrilateral. You know, if you just treat it as a bunch of small triangles, it'll be much easier. So I like to start by just writing all the information in the diagram if they don't do so already. So I'm told that angle SQX is 48. So SQX is 48. So this first part is just telling me line segment RU intersects line segment SX. I mean, it's like you can look at the diagram and see all that, where they intersect. So I don't like to read the non-necessary information. So XQX is, angle XQX is 48. So X, Q, and X. So XQX, this one is 48. 48. What else are we told? We're told that the measure of SXQ is 86. That's the next part. So we start S, X, and then Q. We get 86. So this one is 86. And then the last one, there's more. SWU is 85. So SW and then U is 85. And again, a lot of this might be extra information. I'm just gonna write it down first. And then VTU is 162. So VT and U right here is 162. So then so that's the diagram. What are we trying to solve? What is the measure in degrees of angle TUR? So I look at the diagram TUR. I'm looking for this one. So how can I solve this? So this one, there are actually plenty of ways to solve this. The first way that comes to mind, I like to work with triangles. So I just see that there's this big triangle. So it might not be clear, but there's this big triangle. RTU. Triangle RTU. I can actually make that look more straight. Triangle R. Okay, it doesn't want to be straight. Okay. We have triangle RTU, this one. And so I just want to try to find these top two angles. So angle, I'm going to call it angle R and angle T, so that I can just do, because it's triangle, I can set them equal to, the sum of the angles equal to 180, and then solve for U. So how can I find angle R? So WR, QX are not parallel, so I can't just assume 48 and that are corresponding. That's not going to work. What I could do is I could technically, this is one angle I want to solve. I can solve for these two first. So I'm gonna call angle W and angle S. I can solve for them, which will be easier, and then add to R. So how are we going to solve for first thing, angle S? I'm going to look at this bigger triangle right here. So triangle QXS. QXS, that is the bigger triangle. So I have 48 plus 86 and then S. They have to equal to 180. So 48 plus 86 plus S equals 180. I'm going to put this as Desmos. 180 minus 46. 48 minus 86, I get 46. So angle S is equal to 46. Okay, so that's the start. How do I get angle W? For me, the way I'm going to do it, I can see that this is a straight line. So they have is angle W supplements this angle. Sorry, I'm gonna stop calling it angle W. Angle RWS supplements angle SWU. So this angle is supplementary to this angle is supplementary to 85 because of the straight line. So I have 180 minus 85, 180 minus 85, that is 95. So then I know that this angle RWS is 95. I'm sorry if it was confusing when I was saying like angle W, because that might have been confusing. But then from there I can finally get angle SRW. SRW is 180 minus 95 minus 46. I put that into Desmos. 180 minus 95 minus 46, and I get 39. 39. So I found one side right now. R's angle SRW is 39. I'm just gonna circle it like that because we found it. T is more straightforward than that. All that confused, and there are multiple ways to solve for this. It honestly depends on preference. But yeah, there's if you get 39 in a different way, that's totally fine. For this one, T is it's easier to solve. I just see, okay, similar to how we found angle RWS, angle RTU is also on a straight line with angle VTU. So this angle right here is supplementary to 162. So that means it would be equal to 18. Because 162 plus 18 is 180. And then same thing, remember we're looking at this big triangle. And so now we can finally solve for the angle they wanted, which was TUR. So TUR, which is this one. So then I just do 180 minus 39 minus 18. And it might say, okay, that doesn't look like, let me just first solve it. Then I'm going to talk about that. 180 minus 39 minus 18, I get 123. 123. So then you might look at this and say, wait, that doesn't even look, that looks like it's less than 90 degrees, but that is why they put figures not drawn to scale. And then you put in 1, 2, 3, and that, oops. So 1, 2, 3 is the correct answer. So that is it for today's video. Thank you guys for watching. Again, I have only 2 videos left for the geometry and for the whole series, and then we'll be done with the series. If you have any specific topic you want me to go more in depth in, like factoring or anything else, please let me know and I'll make sure to make a video about it. And thank you everyone for watching, and bye.